Imagine flipping through old family photos and finding your grandfather's birth certificate tucked between the pages of a worn album. You read the date on the document, then check your own birth date. And then you notice the impossible, blood-curdling detail. According to the certificate, your grandfather was born 10 years after you. It's a logical fallacy, a biological impossibility, a minor glitch you should simply laugh off, assuming the clerk who drafted the paperwork made a typo. But what if this mistake wasn't written on paper, but woven into the very fabric of reality? In 1900, the renowned physicist Lord Kelvin addressed his colleagues with a famous remark he would later come to deeply regret. There is nothing new to be discovered in physics now. All that remains is more and more precise measurement. For a century, he appeared to be right. Humanity constructed a colossal, flawless architecture that explained how the universe worked, how stars were born, and how the void expanded, the standard model of cosmology. This was not merely a theory, it was the master ledger of existence, the ultimate constitution sealed with Einstein's equations of general relativity. Under this constitution, everything had its order, everything had its rule. The universe was born 13.8 billion years ago, gradually cooled, and out of the darkness, the very first stars stepped onto the stage in cautious, measured strides. When the European Space Agency's Planck satellite listened to the cosmic microwave background radiation, that faint thermal whisper of the early universe echoing through the freezing void, this constitution was ratified once again. By analyzing the sound waves from the dawn of time, Planck's data calculated the universe's current expansion rate with extraordinary precision. The number was 67. This unit dictated that for every 3.26 million light-years of space, the rate of expansion increases by 67 kilometers per second. The margin of error was practically zero. The debate was settled. Lord Kelvin was smiling. Until, in another corner of the universe, another researcher uncovered a dark secret. To measure the universe's expansion rate, astrophysicist Adam Rees and his team decided not to look at the echoes of the Big Bang, but straight into our own backyard, the stars of the local universe. Their targets were Cepheid variables, stars that act as the lighthouses of the cosmos. The atmospheres of these massive supergiants expand and contract like a beating heart due to the helium they ingest. This rhythmic pulse betrays their true intrinsic brightness. When you calculate the difference between a Cepheid's actual luminosity and how dim it appears from Earth, you are left with an absolute foolproof measurement of distance. A cosmic tape measure. Using this tape measure, Rees and his team gauged how fast galaxies were rushing away from us. But when the results came in, the oxygen was instantly sucked out of the room. The Cepheid stars were screaming that the expansion rate of the universe wasn't 67, it was 73. To an outsider, it was a difference of a mere 6 units, a trivial statistic that looked like a rounding error, something the average person would shrug off. But in theoretical physics, a realm operating on 1% margins of error, this massive 8% chasm was no standard miscalculation. It was a contradiction as earth-shattering as claiming that the planet we live on orbits the sun backward. If the speed was 73, the universe was expanding much faster than the Planck satellite claimed. And if it was expanding faster, the time it took to reach its current size had to be shorter. Meaning the 13.8 billion year age written in the textbooks was tossed into the trash with a single stroke of a pen. The universe suddenly became 1 billion years younger. That was the moment the poisoned arrow struck the very heart of cosmology. If the universe was younger, the oldest star clusters within it became older than the universe itself. Just like your grandfather being born 10 years after you. A supposedly perfect timeline, harboring a massive, glaring paradox. The scientific community initially did what it always does. It went into denial. They called it human error. They blamed faulty equipment calibration. And as their strongest line of defense, they invoked the dust theory. Cephides reside in the crowded, chaotic suburbs of young galaxies. Theorists argued that the Hubble Space Telescope's aging lenses were blurring the star's light together due to dense surrounding cosmic dust, creating an optical smear that gave the Cephides a false brightness. All they needed was a pristine new eye capable of piercing that veil of dust, looking through the darkness like an X-ray. In December 2021, humanity launched that eye into the depths of space, the James Webb Space Telescope. This was not just an instrument. It was a historic gamble, carrying 344 single points of failure during launch. A scenario where a single over-tightened screw could turn a $10 billion wonder into space junk. Its 18 hexagonal beryllium mirrors, folded up like origami, settled 1.5 million kilometers away from Earth at Lagrange Point 2, a desolate pitch-black pocket where the gravitational pulls of the Sun and Earth perfectly balance one another. When its gigantic 5-layer sun shield unfurled, supercooling those mirrors down to minus 233 degrees Celsius, the sharpest eye in human history finally opened. Webb's infrared sensors slipped right through the thick clouds of cosmic dust that swallow visible light, meeting zero resistance. Holding their breath, astrophysicists pointed Webb at more than 1,000 Cephides across 5 different galaxies. The telescope rendered the pixels razor sharp. As hoped, the veil of dust vanished entirely. The Cephides stood exposed in absolute clarity, isolated, naked and brilliant. The math was rerun, the secrets lay bare, and the number flashing on the screen was still 73. The dust theory had collapsed. The source of the discrepancy wasn't pointing at faulty instruments. It was pointing straight at the laws of physics themselves. Humanity hadn't made a mistake. These two wildly divergent expansion rates, 67 and 73, were both simultaneously and absolutely correct. Physicists trying to swallow this impossible truth were soon to face a second, far more lethal blow delivered by Webb out of the dark. When the telescope locked its gaze onto the dawn of time, billions of years ago, back to the universe's fragile infancy, researchers fully expected to see wispy, gaseous, barely coagulated smudges of light. According to the Standard Model, galaxies assembled slowly over immense epochs, built bottom-up as small fragments clumped together. Normally, for a galaxy like the Milky Way to attain its present majestic mass, it had to spend 13 billion years in a relentless process of cosmic assimilation, swallowing hundreds of smaller dwarf galaxies whole. But when Webb's deep space imagery was processed, the shapes blooming on the monitors weren't feeble clouds of gas, they were impossible monoliths. A mere 500 million years after the Big Bang, a cosmic blink of an eye, fully mature, ultra-massive ancient galaxies were drifting through the deep void. They dubbed one the Big Wheel, a delicate, rotating spiral galaxy of pristine symmetry that should have been torn to shreds instantly in the violent, collision-heavy Wild West of early galactic dynamics. Beside it rested the cosmic cigars, bizarre, misshapen galaxies stretched out like javelins, directly defying the dark matter simulations that dictated they had to be spherical. And then they spotted the little red dots, ultramassive black holes masked behind a false veil of starlight, ravenously gorging on the matter around them. The laws of thermodynamics are rigid. For a galaxy to grow so massive in so little time, it would have to convert the surrounding hydrogen gas into stars at 100% efficiency. But as stars ignite, they generate stellar winds. Supernovae explode and blast ambient gas outward. 100% conversion rate isn't just a rounding error, it is a physical absurdity. It is the cosmic equivalent of a newborn baby stepping out of the delivery room to run an Olympic marathon. Slowly, physicists are coming to accept a chilling reality. The early universe did not operate the way we thought it did. Perhaps, at the dawn of time, there lurked a phantom force in the shadows, one we no longer feel today. Theorists call it early dark energy, an invisible hand that suddenly manifested during the cosmos's infancy, hyper-inflated the fabric of space, and vanished without a trace. Or perhaps the flaw lies in dark matter, that elusive architect we cannot detect in any particle accelerator, yet rely upon to form the very skeleton of the universe. Far more unsettling is the grim scenario whispered by early data from DESI, the Dark Energy Spectroscopic Instrument. If the dark energy driving this expansion isn't a cosmological constant, if it fluctuates, weakening or gaining momentum over time, the ultimate fate of the universe might not be a quiet, infinite freeze. It will either collapse back in on itself in a big crunch, or dark energy will run wildly out of check, shredding galaxies, then planets, and finally the atoms themselves, tearing the cosmos apart in a big rip. A century ago, Newton's laws of gravitation broke down when pushed to the extremes of black holes and the speed of light, forced to step aside for Einstein's general relativity. It seems history is indulging in one of its grand rhymes. Pushed to the dizzying horizons of the early cosmos, Einstein's flawless equations have begun to fracture. Models are being patched. The rulebook is being torn up. The history of the universe as we know it is being reconstructed right now before our very eyes, like a colossal blueprint being redrawn from scratch. Lord Kelvin was wrong. Physics isn't finished. It is only just beginning all over again out there in the terrifying dark.